Welcome anyway. It's really good that you're interested in this, so thanks very much on behalf of your kids. We're all going through this process at the moment of trying to refine the folio. 2,000 word externally marked component is a tough gig for a lot of our kids. So I scaffold it as much as I possibly can. And the little PowerPoint I've got here is really a sort of a hybrid between the stuff that I use with the moderators and the markers for the SACE board and what I use with my kids. You've probably all seen that terrific template, if you like, that's been around for a year or two that should help you guide your kids through the folio. If you haven't, I've got a copy of it. You've remiss of me not putting it on this show here, but basically it's what's on the screen here. So what I'm up to at the moment with my kids is I'm up to the evaluation. So we've gone through sorting out the design brief, the statement of intent, and tried to implore on them how important that design brief is, because if it hasn't got enough information, the rest of it's going to fall in a big hole. It's really, really critical. It's a tough piece of writing because, as you know, the word count is 2,000 words is not a lot at all. So what they need to show in their design brief and statement of intent is exactly what they want to design with the idea of manufacturing it, so that when they go to investigation, that drives their investigation. It's a cut and paste, if you like. When they go to planning, one of the first things that I'll talk about in a minute is they need to have a look at, say, 2 or 3 possible solutions to their investigation and analysis, and then start to refine that planning by talking about sequential steps and then talking about testing and modifying. That's what I'm up to with my kids. We're just looking at the evaluation. Of course, the SACE board's made it a bit more awkward for us, hasn't it? Because we're actually going to finish the evaluation before we necessarily finish the product, which makes things just a little bit awkward, but a little bit of guessing and a little bit of goodwill makes it all happen. So that's exactly where I am at the moment. I've got 2 Year 12 classes. I've actually got 3. I've got CAD, Graphic and Industrial Design, and 12 IT. Okay, and in our school we've got 2 Year 12 medals, 2 Year 12 Woods, Electronics, and 3 photo classes. So we've got a lot of Year 12 things happening at our school, and that's because there's a lot of really good teachers at our school who have met the needs of their kids, and they do a fantastic job. So I'm proud of those people. Okay, I'll try and take you through this, and just hopefully it's makes some sense.
You can stay back there for Sue and Colin.
Okay, g'day Sue and Colin and everybody else on the other side.
Just so they can hear you.
Yeah, no problem. Stay here.
Yeah, or somewhere back.
Behind there?
Just out the window. You're on the screen.
You're right. Okay. Identification of a problem, challenge or need. So this is mindful of what I'm actually saying to the moderators and the markers. So this will be something like those people who are involved in that will see this again with a few changes. Needs to be a clear need to be identified, some qualifiers and some criteria and some constraints in it. So you can be thinking of your own kids and how you've taught them about this, if you like, as we go through it. There needs to be a close link to the following design brief as it comes up. The creation and validation of a design brief based on the needs analysis and task identification is the critical part. Statement of intent based on a need identified. Sometimes that's really a bit academic, isn't it? Because you're actually walking in there and saying, okay, we're all going to make cabinets. Or okay, we're all going to be doing a collage, or we're all going to be doing something. So they're not actually generating a need, but so it can be a little bit academic. But in general, kids usually come up with something that's decent there. This statement of intent here will unpack the student's intention. Well, that's what we'd expect to see from it. It needs to be inclusive and so carefully worded so that, okay, I'm going to make a bedside cabinet for my bedroom, and it needs to house the following items, and from that perspective I'd like it to have 3 drawers and a door, and be big enough to house my massive television set that I've got. Cool. Great. When I do that with my kids, I get them to describe it like this. Tell me about the function, tell me about the aesthetic qualities that it's got, and tell me about what constraints you think you might have. And I find that if they write under those three headings, they don't leave anything out. So function, aesthetic qualities, and constraints. I'd be allowing around about 150 to 170, maybe 200 words for that section. Again, this is Steve Reed talking about, this is not a prescriptive thing, but I'm just saying how I do it. Okay? Most important part, if they get that wrong, it's all downhill from there. Really, they're working backwards. The planning. Wait. There we go. Analysis of information to develop an appropriate solution to an identified design brief. Been there. It's a synthesis of information presented in investigation and critical analysis. For the planning, I would be asking the kids to develop 3 possible solutions. So once I've investigated that great bucket of knowledge that they need to design their cabinet or their game or their website or their series of images, you know, we're talking about materials and stuff you already know about, so I won't bother about talking about it too much. Then I've got to go on to the planning section. What I get the kids to do is come up with 3 possible solutions from all of the analysis that they've done in the investigation, in sketch form. Now, if you're talking about websites, some of my kids are doing them, just show me 3 index HTML pages. If you're talking about gaming, show me 3 maps. Give me an idea about what the game's all about in 3 solutions that you've come up with. You're talking about a cabinet, show me 3 different types of cabinets that would satisfy your design brief. If you're talking about, you know, circuitry, do the same sort of thing. And then say, I'm going to choose option 2 because it most closely satisfies my design brief. There's the link straight back to the design brief. Want to see it? Need to see it. Okay, I've even said to my kids, you could do something like, every time you mention design brief, put it in italics. Make it red. You know, make it stand out, make it really clear that you know, the kids know, that there's a discrete relationship between the design brief and the rest of the document. So down into the planning section here is investigation and critical analysis of everything you've done in the investigation. And then select the most appropriate one as per your design brief intentions. And if I'm going to be saying to my kids, make sure you use that terminology, because the markers are going to have a sheet with them, like the one I spoke about before, and they're going to have 10 minutes to mark your kids' work. 10 minutes is not a long time. So make it easy for them. Make sure that they can go design brief, statement of intent, investigation, impact statement, materials, jointing, whatever they need to investigate to manufacture and design their product. On to the next bit, talk about synthesis of information, talk about communication, we'll get on that in a minute, talk about testing and modifying, tick, 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 and then the evaluation, we'll get onto that as well. 4 points in the evaluation, tick, 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 tick. If you're marking their work and all of those things are done, so lay down is there. I say to my kids, if I can put a tick next to every one of those, you're going to get 15 out of 30. And then it depends a lot on how well you've satisfied each one of those ticks. But you leave a couple of those ticks out and you're going to put a satisfactory result. You're going to make it in jeopardy and put it in jeopardy. So it's really, really critical that you understand all of those points have to be satisfied. every one of them as we go through. Okay. The next thing is a really a weird thing in the planning. I find the planning probably the hardest thing to teach. Investigation's bread and butter for us, I reckon. But the communication refers to the entire folio. So when the markers are going to be looking at that will be wanting them to look at images, graphics, communication methods in a variety of ways. I'm going to be, for the first time ever, getting all my kids to submit their folios digitally this year. Last year I did everything else digitally, except for assessment type 3. This year I'm nervously going to put in assessment type 3, so it'll be 1 CD per kid, which the markers are going to have to pick up, chuck into a drive, hope it works. Why am I doing that? Because I'm working in a digital era. I'm working in a digital environment. I'm saying to my kids, what better way to show the marker testing and modifying than to have a CNC simulation running on the screen and showing how you're changing that. What better way to show them about scripting is to have variations in the scripting and then show them how that changes the game. Change the HTML code. Show them how that changes the font or whatever it is that you're going to change with it. I can't see a better way than what we do at the moment, of course, is we hit print screen, we pop them there and we do it that way, which works. But I think when you're working in an environment like I'm working in, I'm saying to my kids, you show me what you can do. You show me, you give me the evidence in the folio, how you've gone through this process of designing this wonderful product that you've got. And for the most part, the best way to do that is digitally. In my CAD class, for example, I'll be saying to them, show me the assembly drawing, put the assembly drawing up, take it apart, show the marker. This is how I tested and modified it, and I can see that these two parts don't actually fit. So then I'll go back and fix it. Now, the interesting point about the way I'm going to do that is that there's still a 2,000 word limit. So what if the kids write 2,000 words and they put in 15 minutes of videos? Not going to work. But I'm suggesting if they write 2,000 words for their folio and they've got 30, 40 seconds, minute and a half of discrete video, AVI file style, pertinent, probably the markers are going to be happy enough to say, okay. All right. Now it's a bit of a risk, but I really think we need to go forward like that. I really think we need to show evidence to the best of our ability. For another example is my minor product for the kids who are doing the gaming will be a DVD showing how to use their game. Best viewed at this, blah 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 blah. That's the minor product. So they need to explain how the game works and how they've constructed it, and the major product, of course, is the game. That's what should happen. Should do that. So in the folio, there's lots of opportunities to go through and discuss that. So the communication is really important. So that's how I'm going to try and get my kids to communicate, is by using images, graphics, as much as they can to explain it. I guess what we don't want to see is, if we can help it, is lots of spelling errors and grammatical errors. And a lot of the kids that we work with are going to make those. We understand that. I understand that. It doesn't necessarily mean that it's poorly communicated, but it's going to make it hard for you to reward them strongly if they've made mistakes at stage 2 level that they shouldn't. And you'd all be terrific markers, and I'm not saying that in a silly way. Ask yourself the question, if you were sitting down marking other kids' work, what would be the first thing that you'd be looking at? Well, I know that the front page would be wonderful. We had a little diagram of what the kid was trying to design. How many times have you sat, well, as a marker, how many times have I sat down? I reckon I've gone through 3 pages of the bloody folio before I can figure out exactly what the kid's trying to design. So show them on the first page, that's what I'll do. Say, this is a cabinet, this is my cabinet if you can. Or this is the first page of the game. Or this is the index page. Or whatever it is. So that as soon as the marker looks at it, oh, okay, this kid's talking about gaming, beautiful, I'm into it. Or this kid's done, a metal project, I'm into it. The kids get that. The wood and metal kids, they get that. They can understand that. They can do that. Lots of images, lots of drawings, lots of diagrams, lots of sketches. That's the communication thing. It's really hard to mark, but I think you know what I mean. Hopefully you know what I mean there. It needs to be concise. Like Year 12 is not about what you put in, it's about what you leave out. If the kids are really thinking about it, they'll have that 2,000 word thing gone down to 3,000 words before you know it, and then you're thinking to yourself, how the hell am I going to fit this in? Well, that's what I'm saying to you. You should be saying to your kids, it's not what you put in, it's what you filter to leave out if your kids are at that level. If they're at the level where they're struggling to get the 2,000 words, a different story. You need to scaffold them a bit more. But try and make it concise if you can. If they use drawings, they need to be clearly annotated and use the conventions relevant to the focus area. What we mean, it's a bit wordy, but if you're in a CAD environment, then you'd expect the CAD drawings that eventually would be put into the folio to be aligned with a relevant drawing standard. If it's not a CAD course, then they just have to communicate. And now that sort of the AS 1100 thing's sort of gone out the window, and each particular CAD package that we work with has got its own set of standards associated with it, like, dimension size and all that sort of stuff that we've grown up for the last 30 years worrying about. Well, probably don't need to worry too much about it. But if it's a CAD course, you'll probably need to lay out to the kids before they start what the conventions are that they need to stick to. So if you're going to hand drawings up in the folio, which we all should be doing, if you've got material stuff, then make sure that they are compliant with the conventions. I would be putting in lots of renders and final CAD drawings if that's the environment that you're working in. I'd be getting my kids doing the gaming thing to put in some screenshots, but again, using the AVI stuff as much as they possibly can to communicate as well as they can with how the game works, what it can be done, how it can be played. I think the problem is going to be is that you've got a whole pile of people marking this thing that don't necessarily know anything about gaming. They're smart, switched on, dedicated, diligent people who are really cool at knowing if it's a diligent piece of work. They won't necessarily know too much about gaming, necessarily. So it's up to the kid to make sure that, as a good communication thing, that they actually show how it works. Or show how their cabinet fits together. Or show, the final part of the metal project or whatever it is that the kids are designing. Somehow or other, there. Now, this part here often gets left out. For goodness sake, do not leave it out. Make your kids have a heading in there called testing and modifying. Testing and modifying is a critical part of this whole thing. Testing and modifying can be done. I've got a whole pile of things down here that you can say. It might be inadvertently done through the whole document. That's true. That's very true. But I'm going to make my kids put in a discrete heading called testing and modifying. Someone designing anything digitally might change stuff 150 times, mightn't they? They might do 40 changes in a double lesson, discrete little changes to a script or to a CAD drawing or wherever. You can't record all them. So as teachers, I think what we can only do is to say to our kids, pick out 3 or 4 of significant changes that you've made where you've tested and modified. Now, that's horrible advice to give because you'll be thinking to yourself, well, what could that be? Well, it could be lots of things. It could be, it might include the following things like CAD assemblies, it could circuit testing, it could simulation of the CNC program or operation, trial assemblies in a workshop, flash error reporting and troubleshooting, coding changes, anything like that, network testing, whatever your kids are doing, so that you can show that they've tested it and it either works or it doesn't, and if it doesn't work, how have you modified it? Really important. Really important. So just to summarise that planning part of it, start off with some solutions to your investigation. It's 3. I don't care how many. Start off by showing that your kids, from the analysis they've done, they've generated 3 solutions to the problem, to the design brief. And I'm saying 3, could be 5, could be 1, 2, I don't care. But show that they haven't just thought of one thing, that they've actually gone outside the square a bit, even if they've only ever going to do one cabinet, that they've actually gone. So show that and say something like, from my investigations, I have been able to devise 3 possible solutions to the problem from my design brief. However, I'm going to go with solution B because it most closely satisfies my statement of intent. Full stop. Full stop. So then you discard those sketchy results. Remember, I'm not saying you do, they're just sketchy results. Then you discard the other 2 or however many you got, and then you start planning a sequential sequence of how the kids are going to go about the designing and possible manufacture of their product, including the testing and modifying. Alright? So thus far, the first part of it is design brief and statement of intent. The second part is, of course, that big bucket of information called investigation. We didn't talk a lot about because I guess you know about that. But that does include the impacts essay, so I'd probably be remiss of me not to say something about that, because I've learned over the last couple of years that to cut the rubbish out of that essay and go, from my investigations I have found that computer viruses are a problem. Great, because I'm designing a website or whatever I'm going to do. So it's seamless. The impact for computer viruses like Trojans are ... referenced. Full stop. So you've identified the impact or the issue, and then you've shown how it's going to have an effect on your product. 400 words, in my opinion, max. I used to get my kids to do way more than that, and I think that was over the top, and it wasn't concise. I used to get my kids to define what a Trojan is and how does it work. Forget it. Acknowledge the fact that it's a computer virus and go straight to the impacts that that computer virus would have on society or the individual or whatever you're going to need. Alright? So that's in your investigation somewhere. Also in the investigation, of course, standard things, and I don't need to go through those, so hopefully I will if you want me to, but I don't think I need to. Materials and all that sort of stuff. One thing I might say about the materials is reference your materials in the investigation back to the MAD apps thing that you do in assessment type 1, because in assessment type 1 you're probably going to be looking at a couple of materials that are relevant to your product. Now, some of my kids, I use DATTA for that, and stuff like that we can do qualitative and quantitative testing on. It's really important that we can do that and graph that. So in the investigation, all you need to say is that I'm going to be using TIFF files for my product because reference assessment type 1. Game over. So don't take up lots of words in the investigation that you haven't got room to take up because you've already done that work. Or you should have, or could have. You know, it's possible kids have changed their mind and understand that. But if you have done that, then don't eat up valuable words in the investigation on the materials. Just acknowledge it. This is the material I'm going to use radiator pine because I found that after these tests it was the most suitable one that I like. Fine. With reference system type 1. All good. Then the planning, been through the planning. Let's have a look at the last one, hopefully. Or we're not. Let me see, mate. My mouse going to work? No, it's not. Okay, the evaluation stuff. I'm sorry that my PowerPoint's not actually doing the right thing. The evaluation stuff, start off with how successful your product was against the design brief intentions. And I would definitely be using that statement. That my product was successful against my design brief intentions because, or it wasn't. And it's cool if it's not, that's fine. But try and say why it is or why it's not. And here's another link, straight back to the design brief. So if the design brief isn't full and informative and concise, the kids will have nothing to talk about in the first part of the evaluation. There'll be nothing there for them to elaborate on. The second thing in the evaluation is get them to talk about the success of the manufacturing or realisation process. So they would have realised it or should have or made it, or at least in part by the time you've done this. So say, what changes would they make if they were doing that again? What were the strengths and weaknesses of their product? Okay? And probably the third thing I'd be looking at in that section would be, again, maybe if I was studying again and I now know what I know, what changes would I make? And the last thing is all about the impact of your product. Now, that can be partly covered in the impact in the investigation, so it's possible to link those two together. What I tend to do with my kids is to get them to talk about things like carbon footprints, life cycles. You know, has your product made anyone's life better or worse, do you think? How long do you think your product is going to stay on the market? One of my kids doing surfboard, a wonderful piece of geometry, put into a virtual wind tunnel. We looked at the drag coefficient of that surfboard. That could last for 50 years because the aerodynamic properties aren't going to change. One of my other kids doing 3D puzzle, put together using a rapid prototyping machine, 3D printer. That could last for 50 years. Beautiful piece of work this girl's done. Love it. Another kid's doing perfume bottle. Probably lasts for about 6 months. So acknowledge that. Get the kids to think about what their life cycle implications are. And I also say to them, look, have a think about that model that's happening in Europe at the minute where they don't give people the right to manufacture articles unless they are prepared to take them back when people are finished with them and recycle them. Does your product fit in that? When you're talking about e-waste stuff, there's a little bit of a problem there in terms of it being redundant, but you can also always talk about its life cycle. For example, is a web page going to be still relevant in 15 years' time? Yes, it is, because it won't be the structure of the website that's going to date, it won't be the navigation system, it'll just be the content of whether it's still relevant. That's the sort of understanding that I want my kids to have. So is the cabinet still going to be able to be used in 50 years' time? Probably if it's been looked after. And if it's made properly, yes, maybe. Okay, so the other 4 things in the evaluation. I'm sorry about my PowerPoint dying there. It was on my Mac, I'd be right, but it's not. The other 4 things in the evaluation. So I don't want to say too much more because you might have a few questions, but just quick recap. Design brief, statement of intent. Investigation, including the impacts of everything that you need to investigate to design and manufacture the product. That's how to say to that's how to get the kids to think about it for themselves. Sit down and write down everything that you've learned or you need to know to design and manufacture or construct that website. That's the investigation. Sit down and write down everything you need to know to design and construct that cabinet. Everything. That's the investigation. Once that's done, onto the planning, get them to generate some solutions, 3 maybe, I don't care, onto some sort of sequential steps to design it and manufacture it, testing and modifying at the end of that planning, onto the evaluation, where you look at, first of all, the success of your product against your stated design intentions. Really, really important, isn't it? Really, really important. And if the kids screwed up, get them to go back and put more stuff in if they haven't done it good enough. Because they'll do some learning, won't they? As they're going along, they'll do lots of learning. Oh, I didn't know you could do that sort of thing. I didn't know about that fitting. Well, you do now, so go back and put it in. You know, there's nothing wrong with that. Make a retrospective document, that's cool. Okay? And in the evaluation, look at strengths and weaknesses, success of your product manufacturing process. So if I was going to manufacture this product / generate this product again, create this website, create this game again, I would do it differently because love that. Easy to do. Or, worked fantastic for me. Didn't have any problems with the router. Worked great. Good. And the last one is that impacts thing, where you look at the life cycle or similar of your product. Put all those together. The investigation is probably going to take 6 to 8, maybe 1,000 words. I think that leaves you about 350 to 4 for the planning, and about 250 thereabouts for the evaluation, and around about 150 ish for the design brief and statement of intent, and make that work. Massage it a little bit here, a little bit there, but probably the closing comments about it all is make it a communication thing by putting in images, sketches, CAD drawings, final product. Should have mentioned that, probably need to say that to the marketers too. There needs to be some sort of evidence of the final product just to make them feel better about themselves when they're marking it. To think, oh, well, that kid actually did finish this. If you can, put that in. That'd be really good so that it's clear. Now, I could talk for a long time, but I don't think I would. Has anyone got questions of clarification?
I've got a couple.